Hello friends, in this video today we are going to discuss about length contraction. Length contraction. So what is length contraction? Suppose an object, suppose a rod AB, it is moving with velocity v, which is very high speed. Suppose an observer is also moving along with this object AB, and another observer which is at rest relative to this object. Then the length observed by this observer, suppose L, and length observed by the observer which is moving with this object, that is suppose L naught. In that case, this L will be shorter than L naught. That is what we call length contraction. So now let us establish a relation between L and L naught. Suppose we have two inertial frames. One is at rest, that is suppose this frame is suppose S, which is at rest, and another is associated with the moving rod. Suppose this is a rod AB and its proper length, that means length observed by the observer which is moving with the object, is suppose L naught, and this is suppose S dash. This frame is S dash. So here X dash coordinate, this is Y dash. Okay, and its origin is O dash. Okay, now you see this AB, length of the rod, is L naught for the observer in the frame of reference S dash, and this is called proper length. And the length of AB is L for an observer which is at the frame of reference S only, not S dash, S. Now here you see, with respect to this system of coordinate, this frame of reference, now remember one more thing. Suppose this object AB or this rod AB is moving with velocity v along x direction, and the frame of reference also moving with this object along the same direction with the same speed v. And here you see, suppose this A with respect to this coordinate system, this frame of reference is, suppose this is x1, and this distance in this endpoint is suppose x2. This is suppose x2, and with respect to this S dash, this is suppose x1 dash. So let me write it clearly. This is suppose x1 dash, and position of this B in B is suppose this position, this is suppose x2 dash. Now what we can say, that in points of AB in S is are x1 and x2, and endpoints of AB in S dash are x1 dash and x2 dash. So here you see, it is clearly, we can say, the length of this rod AB, so that is L, will be given by with respect to, according to the observer which is in this frame of reference S. So this length will be given by x2 minus x1. So it is x2 minus x1, and L naught. So according to the observer which is in the frame of reference S dash, he will measure the length as x2 dash minus x1 dash, x2 dash minus x1 dash. So hope you have understood this. Now, according to Lorentz transformation, what we have got, x dash is equal to x minus vt by root over 1 minus v square by c square. So we have already established this relation. I will provide the link of the video where I have explained this relation, Lorentz transformation, in the description box. So please go through it. So then you will understand that this length contraction. Okay, so now here you see, if you apply this relation here, then what you will get, L naught is equal to, instead of x2 dash, we can write x2 minus vt by root over 1 minus v square by c square minus, and instead of x1 dash, you can write x1 minus vt by root over 1 minus v square by c square. Here x dash, this is for the frame of reference s dash, and this x is for s. So hope you have understood this relation. So then now let us take the LCM here, 1 minus b square by c square, and here x2 minus vt minus x1 minus vt. So if you remove these brackets, then what you will get, so this is trying this turning out to be, here you see, positive, isn't it? So hope you have understood this. Then these two cancels. So what we have got, L naught is equal to x2 minus x1 divided by root over 1 minus v square by c square. Now you can see this x2 minus x naught, it is nothing but L. So what we can write, that L naught is equal to L by root over 1 minus v square by c square, and so we can write L is equal to L naught into root over 1 minus v square by c square. So here you see, this is the proper length, and this is the length observed by the observer which is at rest. Now we cannot achieve the velocity of light, so v is always less than c. C represents the speed of light. Okay, so that's why this term is always less than 1, and if it is less than 1, if you multiply with L naught, so that means when a number which is less than 1 is multiplied with L naught gives L, that means L naught must be greater than L. So which means that length observed by the observer at rest is shorter than the length observed by the observer moving with the same velocity or speed. Let me write velocity here. With same velocity as the object. So hope you have understood. That's all about the Lorentz length contraction. So if you like the video, hit the thumbs up button and share the video with your friends, and if you are new to my channel, please subscribe the channel and help me to grow the channel. Thank you for watching.